as it's ever been. And when I say our, I really mean it. Because of the work you and your NASA...
So ladies and gentlemen, it's my great honor now to introduce the Administrator of NASA, Charlie Gold. Thanks very much, Dave, and thanks to all of you for coming out today, both here in this hangar, but also across the nation at our various NASA centers.
From Mercury through the space shuttle. She also...
This amazing center is preparing to celebrate its 100th anniversary next year.
Her name is Katherine Johnson. She's an African-American woman who grew up during segregation. It's because of the work of your colleagues.
To inflate the outer bags. And when the outer bags inflate the center bag, which water, what it does is it creates basically a barrier to the aft dome, so it slows down the water, and it basically sees about a 10 psi load that's basically constant across the whole basically water will fill that, and it'll actually stabilize the vehicle.
Is that a ballast?
It's basically acts as a ballast. Okay. It basically as a stabilizing element. All these bags will also gain water, and those basically it stabilize the vehicle to maintain it in that stable, they call it stable one, where it's basically upright. On the actual vehicle, we'll have a high pressure inflation system, and we can inflate the bags in less.
So autonomy and robotics is a tool in our toolkit, right, as we're looking forward to enabling new missions, missions like Mars sample return, missions like asteroid retrieval. We'd like to be able to go under the tree canopy, place a sensor, leave that sensor there for some time, be able to understand the world around you and make smart decisions. So you've been here today from PIs, you've been here today from some of our student interns, all within the context of building these trusted autonomous systems within this test bed, but also you looking at my gestures to give you full context. One of the behaviors that we've put in place here is something that we call follow me, is the leader in this follow me behavior. But again, that could be UAV, that could be a scientist saying, please come here. All right, so here we have 4 scientists who are mission specialists, and one of the ways they trust the system, this is actually a trajectory that our scientists are quite interested in executing, this spiral pattern for atmospheric sensing. So this mission could go on, it could actually change locations. We want to very quickly show you a safe behavior. If one of the vehicles should leave the operational area, we have a geo-containment behavior. We take it back to the bench, graduating to the larger vehicles that you see here that can fly outside and on their test bench. These are...
What we're doing here is we're looking at how here on Earth. So what we're doing here is we want to know where the vehicle is in space. So there's a up to 20-minute lag. There's features, interesting features on the surface. And when I move, those features are tracked. And on the right-hand side, you see a graph. You see a little box flying around. What that is because we cannot communicate to our vehicle, and we don't have GPS on Mars. So some of the things that we
cloud will give us where objects are. These objects could be objects of interest, or
right? It has another task it needs to achieve in the mission.
The larger vehicle had a very large prop wash, and it can also respond to environmental impacts. Maybe there was a large gust of wind, and it got pushed off course. It's going to calculate a new path to get back on track and back to where it wants to go.
Great, thank you, Ben. So as I mentioned, this is a hashtag, answers withdrawal. No dashes, no